We are moving to the world of magnetism through this experiment. So we have this person hoisted. So during his class and stuff like that, that's the background. He happened to observe something. He happened to observe that a current, right, flow of charges can actually produce magnetic effect. And that's how basically that's the basis of this entire chapter. That's a starting point, not basis, starting point. Actually, basis also. So this experiment, which he was trying to do, but it turns out to be something else, and he further studied. That's your OIS or okay, I'm not able to pronounce that. OS experiment. Okay, yes. So what is the basic idea? An experiment to demonstrate that the connection between electricity and magnetism. Okay, right? So flowing charges can produce magnetism. So how do you conduct the experiment? You can get this in your exam. Write steps to conduct oyster experiment. So these are the materials needed. A wire, power supply, a compass, connecting wires. Okay. Next. So the arrangement is supposed to be as shown in the figure. Let me put the diagram up. So it's a very simple thing. You have a battery, you have a switch, and you switch it on. So with that, what you do is you keep a magnet around it. Okay. You can keep a magnet around it. When I tell around, it can be below, it can be above, so on and so forth. So maybe something like this. So when you do that, of course, we have the current flowing in and all of that. So when we do that, what happened to this person is he happened to see a deflection. The deflection in what? In the compass. Okay, so that's your compass. So the compass needle, right? So compass needle happened to show some deflection. In what direction and all of that we'll understand, but it moved basically. It was in to the north and it moved. And when he switched it off, it moved back to the original place. Then when he increased the strength or voltage per se, it deflected more. When it reduced it, it deflected less. When you switch the direction, then instead of going to the right, it went to the left. Okay, guys. The point is, whatever changes he did, some other things kept happening over here. So the setup is as shown in the figure. Ensure that the compass is placed near the wire. When apply the current, observe deflection. Now observation. What exactly you will get to observe? It's a very simple experiment. Oh yeah, I do have it as well. I'll show it. When the current flows through the wire, the compass needle will deflect, aligning itself perpendicular to the wire. By conducting further experiment, we can observe the following. So let me actually do this first. Okay, so let's see this. So we have a compass, we have a wire, right? Then this is connected to a battery. So you can see that as of now there's no voltage, and you can see the north is along this. So everything is in straight line. Now when we switch on, can you see that voltage change, and you can see some deflection. Of course, this is a very thin wire and all of that, but still, deflection is deflection, is it not? You can see I think it's voltage or current. Where is it? It is current. Yeah, there's flow of current. So when we switch it off, it's back to zero. So this is not voltage. This was current. Okay. Okay, guys. This is adjusted to current, and I think yeah, it is how much was it? 220 or something. So 20 milliampere, a small current. Okay, guys. So when you switch it off, it came back. I think I'll turn the terminals. Yeah, I turned the terminal. You can see that it is now to the right. I'll show the difference. This was to the left when the current is positive. That is, we are switching the terminals basically. I'm doing it in the background. This was is to the right. That's it. That's the very experiment. So based on this is how it got started, and all the devices, again, your speakers and everything pretty much works on this very simple experiment. The world is that simple, at least to some degree. At the same time, that it is that complex. Human nature is complex actually. At this scale, the physics is quite simple. At quantum scale, it is very weird. I mean, it's not me telling, it's the people who are trying to understand it telling. And you guys can also do that, if you are interested. It'll also be fun. Now, by relocating the compass, so I didn't do that. I think I've done it in some other set of videos, but let me move forward. Above the wire, below the wire, and all of that can be done. Left and right of the wire. So when we do all of this relocation, and we see that there is deflection, and the deflection varies, So by changing the direction of the current, by switching off and on, right? We have done all of this other than increasing the amount of current. That I was not able to show you guys. It will be there instead of videos. Let me try. No, this is a photo. Okay, guys, I think let's not waste more time. So conclusion, the compass needle deflects, indicating the presence of a magnetic field. The direction of magnetic field is perpendicular direction of the current flow. All of this we'll observe. The strength of the magnetic field can be influenced by factors such as magnitude of the current and distance between the compass and the wire. Okay, again, just an introduction, don't think too much. But yeah, the thing is, we have a compass, and when there was a flow of current, actually it will be to this direction. Why? All of that we'll understand. Okay, why not that? Why this? Why not that? Why this? So on and so forth. So it's a simple experiment. He took a wire. He happened to do some experiment related to this similar setup. But the compass needle, which was next to the wire, kind of got deflected. Then he started wondering, was it something in the table or it happened because of something else? And as and when he conducted more experiments, he understood that no, it was the current itself. And repetition of that is this particular write-up, nothing else. Okay. Yeah, you can get it in your exam. So possibility.